Every piece of equipment in oil and gas plants, whether onshore or offshore, relies on strong foundation. But here is the catch. See, even if you miss one single detail or a small detail from the vendor data, the entire structure could fail or it may lead to the construction errors. See, as a structural engineers, our job doesn't stop at steel and concrete. See, we depend on accurate vendor data of equipments to design supports and foundation that can withstand every load, every vibration, and every environmental condition. But see, here is the problem. See, many times vendor documents don't arrive complete or engineers doesn't check them thoroughly. Vendor data is either incomplete, delayed, or misunderstood, and that's where mistakes creep in. See, if you miss even a single piece of information, let's say the equipment center of gravity or nozzle loads, your entire foundation design could be wrong. So what happens when these details are ignored? Foundation may be under-designed, anchor bolt may be clash or fail. Your steel structural framing may not align with the vendor supplied frame, or it may not align with the vendor supplied loads. See, and that's why today I am giving you a complete checklist straight from my experience as a structural engineer, covering both onshore and offshore equipment. So let's break it down point by point. First segment, general equipment location and layout. Always confirm the equipment location coordinates as given by the vendor. Cross-check plan views with north orientation, elevation views and lug details. Check equipment location whether resting it on the ground or on structural steel framing. Second important point, elevation and orientation. See, verify elevation of your TOG/TOS, that is your top of grating, top of steel. See, if these details are not provided, coordinate with the piping or mechanical team. Ensure that supporting elevation details are clear and clash free. Next important segment is support connection details. See, for equipment supported on steel structure, verify connection details between the base plate and structural steel member. Ensure that proper welding or bolting details are included. Next important segment, loads and reactions. Check dead loads, operating loads, test load, wind, seismic and blast loads. Verify whether the loads are factored or unfactored. Ensure that load combinations are consistent with project design codes. Next important part, anchor bolt and base plate details. See, check the type of anchor bolt materials mentioned in the drawing and confirm it matches with your project standards. Second, check anchor bolt scope of supply. Check anchor bolt projection length and confirm it is clash free. See, next is preform holes and embedded plates. See, this should be clearly indicated wherever it is applicable. Verify anchor bolt layouts and spacing against the structural member design. Next important point is grouting and embedded plates. Check that the grouting of equipment should follow all your project standards and vendor requirement as well. Confirm the grout thickness and its type. Ensure that the embedded plate details match the construction drawings. Next important part is seismic, wind and environmental data. See, collect design seismic zone data. Check the design information of seismic, meteorological data, design code and customer's special requirement. For offshore, consider wave, current and marine growth loads. For onshore, account for wind gusts and soil structure interaction. Next most important part is coordination with other disciplines. See, following are the discipline where you need to take care following coordination. In case of mechanical, you have to coordinate for equipment orientation and support requirements. With piping, coordinate for nozzle orientation, access and clashes. With the electrical and instrumentation discipline, you have to cross-check for the cable routing and access platforms. And obviously, for us as a structural engineer, we required foundation levels and soil bearing capacity too for the design part. Next important point is material and coating. See, check vendor data for painting, fireproofing or any specific coating requirements. For the offshore, look for cathodic protection and corrosion allowance. Next important part is transportation and lifting consideration. See, verify equipment weight in different conditions like empty, operating, test and field condition. Ensure that lifting points and lugs design are provided. In that particular as well, cross-check the erection sequence and access requirements. Next important point is operation and maintenance loads. See, while designing, include loads due to maintenance platform, ladders and walkways. Account for man loads, vibration loads and the thermal expansion. Next important part is vendor document and compliance. Ensure that all the drawings, data sheets and vendor prints follow the company and project standards with the latest revision, and you have to check every time when you receive new vendor data whether the loads are changed or not. If there is an impact in your design, cross-check with the client requirements and international codes. And in the last one of the segment is offshore's special points. See, in case of this, wave, wind, seismic and vessel impact loads you have to cross-check. Offshore installation tolerance and maintenance growth, corrosion allowance and fatigue life. Now, here I am providing you one quick ask the vendor summary which you can directly ask your vendor if the sufficient data are not available. Before finalizing your design, here are the quick fire questions you must always ask the vendor. Can you confirm the equipment coordinates, TOG or TOS elevation? Next, are anchor bolt details, scope and materials clearly defined? Next, does the drawing show connection details between base plate and structural steel? Next, is the grouting standard clearly mentioned? Next, have you provided seismic, wind and environmental data as per the project code? Next, are preform holes and embedded plates included in the drawing? And last most important point, has the multidisciplinary coordination has been verified? I mean interdisciplinary cross-check has been done with piping, mechanical, electrical and instrument. So the key takeaway is this: before you design any foundation or support system, don't just rush into stat or hand calculation. Always check vendor data thoroughly. Missing even one of these points can lead to clashes, redesign or even catastrophic failure or any construction site issues. So would you have designed in this way, or did you ever face any issue due to incomplete vendor data? Comment below with your experience. And don't forget, save this video so you can never miss a vendor data check print, and subscribe for more expert structural engineering insights. See, if I have missed any points, you can tell me in the comment box so that we can improvise this checklist further. Always remember, don't just learn software, learn concepts. Thank you.